This presentation will concentrate on Chapter 3.2 with a very quick look at Chapter 3.1, which has already been covered in a previous presentation. That was on the association between two categorical variables. And we looked at some definitions of response variable and explanatory variable. You can pause it here if you need to. And we looked at association between two variables. So association exists if particular values for one variable are more likely to occur with certain values of the other variable. We looked at contingency tables, defined some things, including cells. And then we looked at when we had relative frequencies. And that's shown right here. You notice the bottom row is missing now. And that allowed us to do what are called these conditional probabilities. So if you put this into bar graph form, you can see very quickly on the left-hand side that a conventional is much larger by proportion than organic. The one on the right is saying, what if they were the same size? What would it look like? So we'd like to measure that strength. We did a ratio in class. There are other ways to do it, and we'll touch on that a little bit, but not a whole lot. It's not terribly important. We just can see by a few different ways which is stronger, which is weaker. So we're in the section 3.2 now. And this time the association is between two quantitative variables. And that's going to allow us to graph. What we're going to be graphing this time is a scatter plot. So we're going to have a horizontal axis with the explanatory variable every time, vertical with the response variable. So this has to do with Facebook use and internet use. So if you have more internet use, does it affect the Facebook use? And sometimes they call this penetration, like how much has penetrated the market. And they give you a table. Quite often these tables are accessible through StatLab. And you see the table is quite long, so you actually have to do these things with a calculator. It's going to graph it for you as well. StatLab's another one, but of course during the test you can't do that. If you look at here, there are a bunch of measures on the center and spread for this table. They include the minimum, Q1, median, Q3, maximum, and IQR. So those are done using the median and some measures that are associated with it. And to the left, we actually have the mean and standard deviation as well. And we have it for both the internet use and for Facebook use. And we have histograms. So which might be outliers, if any, in terms of internet use, which might be outliers in terms of Facebook use. What kind of a graphical display would identify potential outliers better? So we're going to look at a scatter plot to look at association and answer some of those things. So how does the dependent variable depend upon the independent variable? How does it change? And we talked about the dependent being the response variable and the independent being the explanatory variable. So we're going to look at a few things. We're going to look at trend. Does it appear to be a linear relationship? Could you imagine a straight line in there? Maybe curved in some way, maybe clusters, more than one cluster, maybe two or three clusters. Maybe there's no pattern. The direction, is it positive? Negative, no direction. Positive, you would interpret to mean as you go from left to right, it goes up. Negative, as you go from left to right, it goes down. Strength, how closely does it fit the trend? So if it's linear, is it really close to a straight line, or do they kind of vary in how far apart they are from it? And then we'll also look for outliers. So this is basically what I just said. I'm going to jump to the next page. And this is the butterfly ballot. This is in your textbook. Unfortunately, the video doesn't let me show quite all of it. But you noticed here in the bottom left, if you go from left to right, it almost could be seen to form a line. As you get further out, it looks like it curves down, and you have one at the very top. That one at the very top on the right-hand side it looks like an outlier. And as you get further out, the dots get kind of spread. So you might look at this as mostly being a straight line. So you can imagine putting a straight line there somewhere, or would you put it to where the dots were pretty close to it. So the correlation is how strong is the association. Now, if it's a positive correlation, it's a positive association. If it's a negative correlation, it's a negative association. Positive one means when one happens, the other one happens also. So as one goes up, the other one goes up. As one goes down, the other one goes down. The negative association means the opposite. As one goes up, the other one goes down. So you'd like to be close to 1. Yeah, either positive or negative. That indicates a strong linear association, and that's the easiest thing for us to deal with. If you notice the things in parentheses, the x minus x bar over sx, and the y minus y bar over sy, those are actually z-scores. One is for the x value, one is for the y value. And on the outside of this is summing up the product of these two for all possible values of x. So you might think of that as x to the I minus x bar, where the I can be 1 to n. In other words, we're looking at every single point in the data set. On the outside, it's 1 over n minus 1, meaning we're going to divide that sum we took of the products by n minus 1. Now, if you look at these series of graphs, they're really pretty instructive. The one at the top left, it's got a positive correlation of 1. The one to its right is a negative correlation, so that's negative 1. And then the one that's 0, they're just scattered everywhere. You really can't put a straight line in there to try to approximate it. If you look at the bottom left, you see 0.8. So you could put a straight line in there, but it's not going to actually touch all those points. And if you look at the far right on the bottom, you could put a straight line in there, and it won't touch all the points, but it can be pretty close to most of them. The one in the middle, r equal 0.4, well, it seems to go, as you go from right to left, it seems to go up, but not really strongly. So we have these things, and the correlations of 1 and negative 1 simply aren't going to happen. That's, if you see data that comes out like that, that's an indication it may have been faked a little bit, or quite a bit. Correlation is not resistant to outliers. So if you have an outlier, it can really affect the correlation a lot. And it only measures the strength of a linear relationship. And that is actually all we have for that section. I'm trying to get the cursor there. Sorry, I'm having trouble finding the cursor to turn this off.